Okay, that looks. So if we just, actually, I don't know what's going to happen when I do this. So you can probably see my screen, but what happens when I do this? Can you still see do you get full screen version of the thing, or do
got a full screen?
Yeah, it's still coming through as full screen, so that's totally cool. That works a treat. Okay, quick heads up, we're live on YouTube. I will edit out the front of this video just so that, just in case, you know, we say anything awkward. Usually I'm the absolute master of awkwardness, so I'm sure, you know, I'm sure it'll all be all good. But while I'm getting set up, you know, just doing all of the socials and stuff like that, do feel free to just unmute yourself, say hello, tell us a little bit about yourself, maybe where you're dialing in from. Obviously, we're at Sydney Serverless Meetup. We've got two awesome presenters, David Mitchell and Rich Buggy, here today. I think you'll really enjoy the talks. But yeah, I mean, part of this is just kind of dealing with the realities of COVID-19 and working from home and stuff like that, and keeping connected. So yeah, it'd be really cool to say hi and hear about what you're up to. My name's Peter Hanson. I'm a AWS serverless hero, and I run the serverless meetup. And just really like working with serverless technologies. I live in the inner west of Sydney, and yeah, that's a bit about me. Enough about me. How about yourself?
I'll jump in. I'm David Mitchell. I'm in Melbourne, but I was born in Sydney, so I have some ties back to the Sydney serverless group. I do quite a lot of work in serverless, both with my day job and the topic I'm going to talk about in a little while. So that's me in a nutshell.
I'm Richard. I'm also in Sydney. I've done a few talks at the serverless meetup before, and I think I attended the first serverless meetup in Sydney, and I've been doing serverless ever since then.
Yep, all of our attendees, feel free to sort of dive in and just say a quick hello if you like. You know, don't be shy. We're all we all started from the exact same spot.
Hey guys, this is Nirmit here. I'll just give a small intro for myself. I'm based in Sydney, and I just started working on serverless framework actually. I'm working on a SaaS startup, and started working on the serverless framework, and I found like a lot of challenging to begin with. So I'm looking forward to, you know, get insights from the experts and share my challenges and learning from the group.
Welcome, Newman.
Odine, I recognise you. Want to introduce yourself, mate?
Sorry, I was having some audio issues. I'm Bodine. I work with David at Deloitte. Well, don't work with him, I know of him, same department. And he kind of piqued my interest in regarding what he's using serverless for, and I thought I'd come along and take a look.
My name's Timothy Burke. I'm in the same boat as Bo. I'm in the same area as David as well. And I've done integration work with serverless, but very rarely looked at actually building full end-to-end systems. And yes, I saw this one coming up and decided to join.
Welcome. We will get underway pretty soon, but just thought I'd put up a screen so that everyone knows where you are. Yeah, if anyone else wants to say a quick hello and introduce yourself, otherwise feel free to, you know, pop in the chat and say hello. We have, I think we've got Daniel Zivkovic joining us all the way from Canada. He runs the Serverless Toronto Meetup. Perhaps, Daniel, you might be able to say hello.
Hi, everyone. I'm driving. I don't want to get tickets. It's good to be with you.
Nice. Welcome.
Thank you.
Awesome. Well, when David's ready, we might get him to get us started. But yeah, so basically we've got Rich Buggy. He's been around the traps a few times. He's going to take us through image processing with S3 buckets and S3 event-driven Lambda functions. But first up, we've got David Mitchell. He's a specialist director at Deloitte. Yunji Lin, who presented with us last month, he put us on to David, and I think he's got a really exciting talk for us today. Both talks aren't going to really take us through any code, but I think they're really good examples of what you can do with serverless. David's going to take us through building and running a serverless futures trading bot. So you can literally do a whole raft of really fascinating things with serverless. So really the sky's the limit. There's this new term called server-full applications, and I think that'll really ring true in David's talk. So without further ado, I will let you take it away, David.
Great, thank you. Can I share? Please let me share. Okay. Can you guys see that okay? All righty. So yeah, I'm going to talk about building a serverless trading robot. This is something that's kind of fascinated me for a few years before I got into it, but yeah, it seems to work fairly well. So let me jump across. So my background, I've been trading futures, bonds, and currency markets for 23 years. Over time, I've sort of refined my trading system to become more and more system-driven, so it's less and less discretionary decision-making on my part involved. I work in IT as my day job. I work at Deloitte as a specialist director, and I'm sure I'm not the only one who has fairly unpredictable demands on my time during the day. So I'll turn up for work at in the morning, expecting a nice clear run for the day, and then I'll get dragged off to do something else, fix it for 6 hours. It's completely unpredictable on my part. So I have to find some way of trading when I can't be guaranteed to devote attention to the markets. What I found was that time poorness was affecting my trading performance. So the markets I trade, I'm normally wanting to place orders around 10 o'clock in the morning, East Coast Australia time. And that's typically the time when we have stand-up meetings and crises blowing up. And yeah, it was awkward to juggle. What else is there? So before, as part of my background, I worked at the ASX and for various brokers in the 80s. That's where I kind of got my first taste of markets and how we could use, how having a knowledge of IT would play into that space as well. So I'll jump on. This is what my trading competition used to look like. I'm sure some of you have probably seen movies like Trading Places, Eddie Murphy and Dan Aykroyd, lots of people standing in a room yelling at each other. I actually started out in that environment at the ASX. So it used to be all open outcry trading where there's a bunch of people standing around yelling at each other and people scribbling down orders on pieces of paper. But that's, strangely enough, the world's moved on since then. And the trading competition these days looks a lot more like this. So there's companies with monstrous big data centers full of compute doing whatever they do. They've got their own custom hardware and ASIC chips that they build solely to work on trading systems. They've got teams of guys sitting in front of huge arrays of the screens, kind of like what I'm sitting in front of now, actually. They've got worldwide networks of companies doing arbitrage trades against each other. So they buy something for 1/4 cent cheaper in the UK than they can buy it for in the US, and they instantly swap stuff around. And they're running fiber across the wilderness essentially to try and make their latency as low as possible. So that's the kind of guys I'm up against. And I think, well, I probably don't have quite the money that these groups have, so I have to find another way to compete with them. So I'm what's called a systematic technical trader. I only deal with numbers that you can see on that graph there. So I look at the opening price at the start of the day, the closing price at the end of the day, the high and low prices during the day, the volume that's being traded, and the date. That's all I look at, is that chart there essentially. Stuff I don't care about are things like news, companies forecasting their sales, tips from various forums, earnings per share, and all that other stuff that you can get out of the newspaper. What other companies are doing, all the complex options strategies like iron butterflies and straddles and strangles, and God only knows what else there is. I actually very rarely trade options, although right at the moment I have an options trade running that was just one of those opportunistic ones that comes up. So essentially, the model I built was it's a trading system that requires almost no thought on my part. And that's partly a realization that I'm the biggest problem in my trading system. I make mistakes. Occasionally I try and make things more exciting than they should be. Sometimes I'll go looking for trades that aren't there. So I wanted to just remove me from the picture as much as possible. This system adapts to different market conditions. So it doesn't matter if the market's going up like it is on the right-hand side of that graph, or if it's going sideways like it is at the left-hand side of that graph, or if it's going down. The system just adapts itself to whatever market conditions are around at the time. And it's incredibly boring to execute. So one of the things I learned trading is that boring is generally good. It's a matter of clocking in, doing what needs to be done, clocking out, and getting on with something else. There's almost no thought, as I said, goes into the way I trade these days. So any questions on this? I realise this is probably a domain that people aren't across.
So Dave, it sounds like you have a winning algorithm already, right? Like, apart from the serverless aspect of this bot, it's actually your winning algorithm that you put inside the bot. Yeah.
It took a while to get to that. So it took me probably 5 years to become consistently profitable, but now it just works for me. I tweak it from time to time, but by and large, I've been trading the same system for nearly 20 years now.
So Lee in the chat has a really interesting question. I'm keen to know as well. What returns are you getting?
Oh, what returns am I getting? How do I answer that? Better than the industry average. I'll say that much. No, it's quite profitable. I think as a small trader, you have a bunch of advantages that big institutions don't have. When the market, there's at times when I just don't know what's going on in markets. So as I was saying to Peter a little while ago, there was a time last year when the price of oil actually went negative, a drop below zero, and that makes no sense to me at all. I can't understand what's going on. So I can just say, all right, I don't know what's going on. I'm just going to sit out and do nothing. The other big advantage I have is that my trades are so small, they don't move the market at all. So I remember when I was working for companies like Goldman Sachs, NAB's institutional trading, they would put in trades that were a large enough volume that they'd actually move the market themselves. Whereas I don't do that. I just kind of float along on the surface and try and make dollars and cents where they're making millions.
David, another question. What time frame do you trade on?
Lee, I trade on daily timeframes, almost exclusively. When things were going a bit ballistic, like they were during the GFC and last year when COVID, Trump election, Brexit, I get down to trading on an hourly time frame, but it's 98% of the time I'm trading end of day.
And Dave, you mentioned that you are using technical analysis, right? So you're not using the quantitative sort of method.
That's correct.
Yeah.
Yeah. All the tables that appear in newspapers, I used to look at them because I thought there was some sort of brilliance behind all these numbers, but at the end of the day, it didn't make me any money. So, but my whole trading system has actually got simpler and simpler over time. It started out ridiculously complicated, and I just pulled more and more out of it until it just works and it's reliable.
So, is there any machine learning involved, or?
You know me well, Ewan. I have investigated machine learning. The problems is that there's too many black swan events and not enough data for the time frame that I trade in. So there's typically, 252 trading days in a year, give or take. There's not that many markets have been around for long enough to have, tens of thousands of days worth of trading. I can't remember what the number is for the Australian Share Price Index futures, but it started on the 16th of Feb 1983. So it's, 38 odd years. It's just not enough data to work with for machine learning. That said, I did do a course at Coursera, I think it was, around machine learning and trading, and it was quite simple to sort of get 10% better performance than you'd get by just a random trading approach. So there is value in it. It doesn't work for me, would be the way I put it.
Where do you get the data from?
There's a number of spots. In fact, I'll jump onto that in a couple of slides.
Okay.
Rich. All right, I'll move on. So my original inspiration for this was this book. I spotted it online and thought, oh, that's an interesting idea, building trading bots using Java. As I started to read through that book, I found out, my opinion is that it was pretty terrible, but it sort of planted the seed of the idea in my mind. The algorithm that this guy uses is a fairly simple moving average algorithm. It makes money when markets go up or down, but when they're going sideways, it'll cut your account to pieces. So my suggestion would be to don't use that algorithm, or if you do, don't use it as a learning exercise rather than actually trading real money with it. So in terms of, my starting point was around 2016, and I looked into this then, and so I looked into a bunch of the trading systems that were on the market at that point, though there's a lot more now, but there were a few around then. And they just didn't fit the lifestyle I wanted to create out of this. So I know as an IT guy that computers that I control can be unreliable. Things get updated and break things, and cloud systems in general are just far more reliable than any computer that a person like me would deal with. And as a trader, the trading system that you use is your edge. That's where you make your money from. And while there's a lot of Python code out there for trading algorithms, I really didn't want my algorithm written in Python code running on someone else's computer. There might be a bit of paranoia attached to that, but I'd rather sort of keep my algorithms to myself and not expose them out to the world. So yeah, the conclusion I came to was I've got to build my own system. And as a bit of background, I actually started building it on a Raspberry Pi because, naively enough, I thought Raspberry Pi, that's pretty cool. I'll start with that. But it didn't take very long at all for me to switch over to cloud systems. So yeah, to Richard's point, there's a number of sources you can get for loading historical data. Hopefully that's readable. There's sites such as Quandl, O&A, Yahoo Finance, and any number of sort of free or free-ish data providers out there. Most of them just provide data as simple JSON, CSV, or Excel format data. Typically, you've got to register an API key with them, but that's no big drama. You register an API key, you send them an HTTP GET, and a big bunch of data comes back. The way data for different markets becomes available at different times of day. So at the moment, I primarily trade in Chicago, but obviously the time zone in Chicago is different from Australia. I trade in Australia from time to time. I've traded in Japan. I've traded in London, but the data for these markets comes out at different times of day. So I've just got a CloudWatch job, which triggers a bunch of Lambdas to go out and essentially drag down data from these sites at the corresponding times of day. I started out trying to time it exactly to the minute when these data became available, but then I realized that CloudWatch and Lambda is so cheap, I could just trigger it every 5 minutes during the day. So I just have a CloudWatch job that goes out, kicks off a Lambda, drags in some data, compares it with the last set of data I got from that site and said, okay, if the data's changed, then that's the data I want to work with. If the data hasn't changed, I'll just throw it away. If it hasn't changed since 5 minutes earlier, clearly there's been no update. And then those Lambda functions all munge all the various data formats into a standard format called EDN, and saves those EDN files to a directory inside an S3 bucket. So it's about as dumb as a system could be, but stupid means reliable as far as I'm concerned. Are there any questions particularly about EDN? Because that's a decision that I kind of regret.
I don't know EDN, so I can't actually ask questions about it.
What's the EDN?
So EDN was, back in 2016, EDN was positioned as the replacement, as the future of JSON. So it stands for Extensible Data Notation. It was designed to fix some of the limitations around JSON, but it never took off. At the time, I thought, wow, this deals with a bunch of the problems I have with JSON, but I suspect I'm probably the only one in the world who actually uses it at this point. Yeah, sometimes you bet on the wrong horse, is the way I'd put it, but there's no real incentive for me to change, so I just keep using it.
Question from me, David, is S3 your data store and Lambda your compute? I guess, other options could be, you could spin up a Postgres database or something like that, but is it fair to say, S3 is your database in a sense?
Yeah. S3, I just use it flat files. I could load the data into a database, but all I'm going to do after I write it to the database is read it once anyway. So there's no real benefit in using a database. The whole system runs on Lambdas, S3s, and CloudWatch. There's nothing else to it. So I'll jump on. In addition to scraping data from the various data sources out there, I also drag it in from, I guess, the normal trading tools that I use. So I used to use a tool called Profit Source. I now use another tool called Optima, and they both have data export capability. So again, I can just drop those into a bucket and use another Lambda function to pick up those files as they appear and convert them to EDN and save them across. Again, it's a pretty dumb solution, but it simple works in my observation. The other aspect is that I tend to travel around a fair bit. So I use an Amazon workspace to run my Optima trading software. And that lets me essentially drive Optima remotely. So from an iPad or a Chromebook, which are normally the two tools I carry around when I'm traveling. And again, I can jump into Optima on the AWS workspace, save a file off into a bucket, and then the Lambda function will pick it up and convert it over. Yeah, I don't think there's. The other aspect of that is that the data I pay for with these tools is generally a higher quality than the data I get from free sources. So while I don't use these while I don't use data from Optima that often, occasionally there'll be anomalies in the data that I get from the free source, and I want to confirm it with Optima. Or I'll just be poking around a random chart and find something that looks interesting, and I sort of want to run the system against it to see what it says. So I'll jump on. As I said, there's a lot of reuse of this little lambda symbol. So when the data gets saved to EDN to S3 as an EDN file, that triggers a lambda function to run my trading bot. That trading bot essentially picks up the data, the raw data out of the EDN file, and spits out orders to be placed for those markets. The orders themselves are saved as an EDN file, again, in a different directory on S3. And the particular algorithm I use is pretty slow to run. It takes about 5 minutes to execute on a Lambda with 2 gig of RAM tied to it. Now, I could optimize that. In hindsight, there's ways I could have done things differently, but when I'm trading on a daily time frame, 5 minutes to process data doesn't really mean anything to me. Sure, 5 minutes is fine. When that order appears, when that Lambda function executes and writes an order to S3, it in turn triggers a whole bunch of Lambda functions. One of them just emails the order to my Gmail account. One of them uses a tool called Push Bullet, which sends the order to pretty much all the devices I have. So it pops up on my phone, it pops up on iPads, pops up on whatever computers I'm using. Push Bullet's just one of those services. It's essentially a peer-to-peer messaging service. So unless I'm out of network range, I typically get that notification within about a minute of the order being generated. So I can be out in the park, doing whatever I want. The message pops up on my phone with an order, and that's when I know that I'm ready to go. I did initially try placing those orders directly to brokers, but what I found was that there's two real problems. One is that the brokers' APIs aren't as reliable as I'd like them to be. So occasionally they'd be down or off the air, and I'd have to deal with a whole bunch of error detection and management. The other side is that when I'm trading on correlated markets, I need to control my risk a bit more closely. So by correlated markets, I mean that markets that tend to move in sync with each other. So what's an example? The oil price and the Canadian dollar price tend to move in very close synchronization with each other. So if I'm trading Canadian dollars and I'm trading oil at the same time, essentially I'm taking double the risk. So I want to be able to manage that risk. And so I kind of bounced around ideas about how to deal with that. But at the end of the day, I thought it's easier to just place the orders myself. I'll get the notifications sent to my devices, and then I'll jump on the broker platform and place the orders myself.
David, can I ask a quick question? I do have to jump off at 11:30, so I thought I'd squeeze it in quickly. While I love the approach, did you investigate like platforms, like algorithmic trading platforms that exist today? Like Quantopian, QuantConnect, those sort of things?
Yeah, I keep an eye on Quantopian. I've looked at quite a bit, but again, I feel like I'm forced to hand over too much information to them. So the value I have is in my trading algorithm. I'd rather just keep that to myself and deal with this.
Yeah, thank you. And it's an awesome learning opportunity as well to learn all these things and not be limited by, I guess, other people's opinions. You can just do it yourself.
Oh yeah, there was a lot of learning went into this. I mean, there was a lot of false starts and bright ideas that got rejected, but this is where it landed. So in terms of lessons learned, there was a bunch of them actually. Using Lambda and S3 in particular for sort of low volume projects like this is essentially free. And I'll go into my costs in a couple of slides. I've got evidence that S3 is the most reliable AWS service. So basing things around S3 is probably the most reliable platform to work on. virtually all of the other AWS services are based on S3. So if S3 is down, nothing works. The serverless platform at serverless.com was a great choice. Made my life a lot easier when I found that and started using it to deploy software. Using that approach of cascading events to trigger Lambdas is more reliable than I would have expected. So just the event being when a file gets saved in an S3 bucket, that triggers a Lambda function to do something. And when it saves a file, that triggers the next Lambda to do something. So this kind of cascading sequence of Lambdas, and it's been extremely reliable. I thought they would probably be a bit flaky, but it wasn't. Being able to choose different languages for Lambda functions is really nice in practice. So I've used several different languages in building this, but I just picked the language that was best for the specific job I was trying to do. There's the startup problem where it's just tough being the solution designer, the architect, the developer, the tester, and the only customer. You have to make a bunch of decisions that sort of go against your own personal feelings to some respect. In particular, it's postpone any decisions that lock you in for as long as possible. Don't make decisions. Don't make decisions that commit you to a path until as late as possible. You need to plan ahead, but not too far ahead. So if I was planning, months and months out, I probably wouldn't have actually got anything done. You try a lot of ideas that fail, and that's actually a good thing, because trying ideas out and finding they don't work is one of the best ways of learning, because it helps you focus on what it is you're trying to build. It's sort of continually challenging your own assumptions is great in this. Expect to rewrite code that works. I guess probably most people have come across that. You write something that works and then you go back and rewrite it later to make it better. And the toughest part is actually finishing something. So it's very easy to start a project like this that's open-ended and keeps going and going and going. But I set myself a specific time period, I think it was about 2.5 months, to actually build something that worked, or I was going to walk away from it. From a software architecture perspective, I probably should have decomposed my trading algorithm into lots of smaller Lambdas. As a trader, I don't care, it works. And this is part of that sort of startup problem. It's probably pretty inelegant as far as design goes, but it works. So I just leave it there. Next one was around Eden versus JSON. Eden looked great, but at the end it didn't pan out. Again, as a trader, I don't care. What I've got works, and I'll probably stick with Eden for the foreseeable future. In terms of trading indicators, so some of the algorithm, part of the algorithm I use is easy to explain visually on a chart, but extremely difficult to express in code. And some of the things I was doing took a lot longer than I thought they would. If low latency or minimizing cost was a concern, I'd go with a statically compiled language, Go, Rust, and Haskell. I've built Lambdas with all three. There's a sizable improvement in speed and cost using those languages. As it is, I don't particularly care. Testing serverless functions is a bit of a challenge. My suggestion is that you work out how you're going to test functions before you even choose languages. It's very easy to get locked into a language choice, and then when you try and work out how to test code you've written in that language in a serverless function, it's not that easy. Local stack I tried and rejected. I found it could be handy, but it brought its own challenges. Almost all the testing I do is on my own laptop. The public cloud vendors' serverless interfaces are very well defined and battle tested. They just work. So Lambdas just work. Google Cloud Functions just work. The testing focus should be on those interfaces, not on testing those platforms themselves. So I'm testing the data that gets to my Lambda function as opposed to testing the interface. For this particular use case, being able to test how I implemented the trading algorithm was the #1 priority for me. So I chose a non-obvious language because it was just a great fit for this type of application. I spent a ton of hours creating different data sets to work out what orders I should generate, and then wrote tests to confirm that those orders were generated. And I spent a lot of time optimizing the quantity of data I used. So I think I landed on 11 years worth of data was the optimum amount for me. My test code's about 3 times the size of the code that's being tested. And I use a ton of generative testing to create test scenarios I wouldn't have thought of. So I don't rely on myself to be able to guess at what problems might come around. I just use generative tests to do a lot of that work for me now. As a personal view, I think it's far easier to test code written in functional languages than OO languages. There's just a bunch of mechanisms in the functional language that make it easier to work with. So bottom line, my total costs are about 8 cents a month. For S3, my Lambda executions are free because I don't have enough of them to cross the threshold. I spend about $45 a month on that AWS workspace. I think I've had 1 day outage in about 5 years, and that was when S3 blew up. So it took out basically the whole world. My mistakes are down by about 80%. I used to make mistakes just through being human, and now they're down by about 80%. The stress on me is far lower. I don't have to find time in the day because the computer does all the work and I simply enter the orders. I can scale that to any number of markets I want to. And now I'm down to spending about 5 minutes a day on placing and updating orders. So the total time I invested trading is about 5 minutes a day, and it's profitable. Future plans, you can probably see them there. I realise I've been talking for a while now. I'm planning to open source everything except the algorithm, but I haven't got around to it yet. Yeah, and some final thoughts about serverless. It's great for trying out ideas, for low volume and personal projects. Having that near infinite bandwidth opens up some interesting possibilities. As I said, S3 is the most reliable AWS service. Testing the functions can be tough, so think about that first. When you're running on the cloud, it's not your computer, so it's more reliable, but more stuff can go wrong. So you have to adopt a bit of a system mindset in how you run these systems. You can't just say, all I'm responsible for is code. You have to think of, well, what happens if S3 goes down? What happens if Lambda goes down? How do I deal with those sorts of things? And the final point is considering the lifetime supportability of your code. So I've written code in Node and then I've had to come back later and replace it because Node versions rotate so quickly and AWS support drops off. So I would probably tend to stay away from Node as a language for writing Lambda functions. That's about it. I feel like I've spoken for about 3 hours, but anyone got any questions?
Oh, just first of all, round of applause virtually, of course. I think that was a really fascinating presentation. I've got a couple of questions, but definitely want everyone else to jump in as well, because I think we've had some really good questions. I think it's really piqued a lot of people's interest in what's possible with Lambda. So just real quickly on the architecture, have you got Lambdas that are just kind of getting triggered by CloudWatch events every 5 minutes to go out to those stock exchange APIs, fetch some data, and then check the current data in the S3 bucket to see if there's any change? And does it sort of drop in some change data, which triggers another Lambda function to score it, run your algorithm, and then drop maybe those orders into another S3 bucket, and then you've got an S3 event-driven Lambda to then send you a notification to say, hey, David, got some great orders for you to place. Is that roughly the architecture?
That's exactly it in a nutshell.
Oh, okay. Yeah, cool. Yeah, that's really, really fascinating. It's just like, I think, you got it in one, like the simplicity, but the power of it is just incredible, isn't it? And, that's a really smart way to get it done.
Thank you. I saw you had your hand up a second ago.
Oh, I was clapping.
Oh, okay.
It was a virtual clap.
Oh, thank you.
Yeah.
James Litton has asked if you can send your slides out. I could probably send it out if you've got like a PDF or something like that.
Yep, I can do that.
Daniel Zivkovic has said, hello from Toronto, everyone. Thank you. Shout out to Peter. I was driving. Nice presentation, so just
Thank you.
Yeah.
What was you mentioned before that you went to your own personal stack to start with and then moved over. What were the drivers behind that, or the events that triggered that movement?
The main one, as I said, I started on a Raspberry Pi because I thought I could just stick that in a corner, never have it update, just leave it running forever. But the memory barrier on the Raspberry Pi at the time was a gig. And as I started to dig into it, I thought I want to use Clojure as the language for writing the algorithm. Clojure runs on top of the JVM, and there was no way it was going to fit into a gig. I tried, very quickly realized it wasn't going to be viable and moved on.
And then from there, you went on to AWS.
Yeah.
Yeah. Okay.
I think this conclusion that you have here is quite valid for all use cases of serverless, whether it's on Lambda or Azure or GCP. And the flow that you sort of described around sort of Lambda picking up something, putting it into a bucket, triggering the next Lambda and then the next bucket, have you sort of considered using a more workflow orchestration service such as step functions?
Yeah, I did look at that, but step functions weren't available at the time I wrote it.
Right.
And again, it comes back to, as an IT guy, I'd want to be using the latest and greatest, the simplest approach. But as a trader, I want something that's rock solid, reliable. And this has been rock solid. So
yeah,
that's one of those trade-offs that you sort of have to make as you're going along.
We were all having a joke that you could afford an Amazon workspace, so you must be making some money.
Yeah, that's not cheap, is it?
No, but yeah, fascinating. If we've got any questions, I guess you can hang around for a little bit longer, David, in the chat.
Absolutely.
Just had another one come through. Just a comment, just very informative presentation. Thanks, David. So yeah, and just let us know if you can PDF your slides, and I'll send them out. But I think this is, super inspirational. So perhaps we might even get you submitting to the CFP for Serverless Days ANZ once we get that out in the wild, because I'm sure people would be fascinated with the follow-up on this one. This is great. So thanks so much.
Oh, cool. Thank you, guys. Thanks for all the kind words.
No worries at all. Thanks for coming along. Up next, we've got Rich Buggy. He's going to take us through some image processing with S3 event-driven lambdas. So whenever you want to, Rich, take it away. You're on mute.
Just trying to work out how to do this thing again.
Yeah.
See if I can. Oops. All right.
All set.
Hopefully I'm all set. You can see everything. Off we go. Yeah, so I'm basically going to talk about the S3 notification triggers. So the last couple of places I worked, we've had to do some image processing off S3, primarily around resizing images. So the goal is fairly simple. Sorry, I'm not sure if you can see that off there, but anyway. So the goal is fairly simple. So we've got a source bucket. We want to do some resizing, and we want to put it into a destination bucket. So it sounds really simple. So, AWS and S3 has these things called notifications, and you can put a Lambda in the middle there, and you can tell your S3 bucket to resize to Lambda, and tell the Lambda then to go and put it into the destination bucket, and we're all done. Hooray. In theory. In practice, we've got a slight problem, otherwise known as CloudFormation hates you. The problem with this is that the configuration for the notifications for the S3 bucket are part of the S3 setup in CloudFormation. In other words, S3 needs to know about the Lambda in order to be able to set up the notifications correctly. The problem is that the Lambda needs to know about the S3 bucket in order to be able to give the Lambda the permissions to actually read the files from the S3 bucket in order to do the resizing. So we end up with the chicken and egg problem. So, that's it, all over, let's go home, unless we can find a solution. And it turns out there is actually a solution, and it's a solution that does help with some other things a little bit later on, and that's adding a queue. So what we can do is put an SQS queue in the middle of it, and instead of configuring S3 to send the notifications to a Lambda, we can tell it to send the notifications to an SQS queue, and then we can tell the resize Lambda, instead of getting the messages directly from S3, you're going to get it from the queue instead. So that sort of, takes care of it, and, huge success. Everything works great. And then Brad from marketing decides to dump 250,000 images into the source bucket. If you've ever done anything with Lambdas, you'll know that it will scale like crazy. So, it's going to try and keep up with this. That's not potentially a good thing. If, this is a production system or production account, you're going to start to hit account limits. You might have other services suddenly start to fail. So this may or may not be Brad from marketing. This may or may not be the marketing department. So it turns out adding limits adds stability. So in this case, one of those things you can do is you can tell the Lambda that you don't want to execute more than a certain number of, you want to have more than a certain number of invocations running at a time. So you can effectively throttle the notifications coming off SQS. And everything's great until Brad notices some images are missing. This is probably more like the marketing manager, and I have had marketing managers literally going, where are they? What's going on? They want to know what's happening. Why aren't these images here? So the missing images, so you're all good in the source bucket. You can see the images are there, but they're missing in the destination bucket. So what's going on here? And it would be nice to know when things stop working. So typically when this happens, the culprit is going to be your Lambda function. So your Lambda might have timed out. The image might have been too large for the Lambda to be able to process. Maybe you need to increase the memory size. It might just be that you've deployed a version of the Lambda that has a bug in it all of a sudden. You're adding support for the latest image format and you've broke everything. So the solution for this one is to add a dead letter queue. So what will happen is we set up a second queue, and we tell the Lambda, we configure this on the Lambda so that if the delivery of notifications from the original SQS queue, from our S3 bucket, fails for some reason, they end up on the dead letter queue. We can then set up alerting off the dead letter queue into a CloudWatch alarm. I know it's the wrong logo, but what will happen then is we basically say, look, if there's any messages on this queue at all, you need to raise an alert because something's gone wrong and there's an image here that needs to get processed. So what about recovery? Having something like this is great, but it would be really nice if you could just have the system recover automatically once you go and fix the problem. So, it might be a day later or 2 days later, and you've managed to, you come in Monday morning after deploying a bad version on Friday, and you see all the messages in the dead letter queue, and it's like, well, I've now got a couple of thousand images I need to process correctly. So you can do this using a pattern called Lambda redrive. So in this case, what you do is you set up another Lambda function, and the entire purpose of this Lambda function is to read the messages from the dead letter queue and to just push them back onto the notifications queue again. This will then cause Lambda to perform the resize and hopefully get them out to the destination again if you fixed everything up. Do not automate this is the one piece of advice I will give. It's the first part there, you can sort of see where we do the notification SQS onto Lambda resize. We've got the SQS set up as an event source for the Lambda. We don't want to do that here with the redrive. We want to actually have this redrive run as a manual process. And the reason why you want to get that run as a manual process is if you don't, and you've actually got a bug still sitting in there, you're going to effectively implement an infinite loop where it's going to be the notification comes in, the resized Lambda fails, drops it onto the dead letter queue, new Lambda redrives it back onto the notification queue again, fails again, and just keeps going. So you don't want to go and automate that particular part of it. And that's it. I don't know why I have desktop up there, but anyway, wrong words. Any questions?
Kind of just going back to the beginning, Rich, the reason why you had the SQS in the middle was because of cloud formations, circular dependency.
Yep. This one? Yep.
So what you were trying to do is to have the S3 in one set of cloud formation and then the Lambda in the other cloud formation, but S3 needs to know about the Lambda, but Lambda needs to know about the S3.
Even if you want to have them in the same cloud formation, you have a circular dependency. It doesn't matter. You still got the problem that what you want to do on the Lambda is you want to give the Lambda access to access the S3 bucket. So unless you say you can just access every single S3 bucket, you need to actually give it a bucket ARN, and you can't give it the bucket ARN until the bucket's created. But you can't, if you're setting up your S3 bucket so that your S3 bucket also puts the Lambda in place for the notification, then you get this circular dependency, so you can't actually deploy it.
Okay, interesting. Because I need to dig up the code. I've done something like this before where the S3 was in a separate cloud formation that's already done and dusted, is deployed, right? It exists. And the Lambda had to come along and then trigger off that bucket. There was a special syntax that wasn't in the typical sort of Lambda examples. It's a special trigger that you have to then set up that can link the two together. I'll have to dig up.
Right. This sounds like some sort of either post-deployment thing or...
It's a post-deployment, yeah. So like it's already exists, but then you add an extra trigger so that the two gets linked together.
You can also do like hacky, tricky things where it's like, I'm going to deploy one cloud formation first, and then that's going to deploy the S3 bucket. So now I know what my S3 bucket is. So now I'm going to deploy a second cloud formation stack, and I can tell the second cloud formation stack, this is the ARN for the Lambda bucket somewhere else. And then you can go back and you can redeploy your first cloud formation stack again. And you can now say, oh, by the way, when you're doing it, here's the ARNs for all the Lambdas you're supposed to trigger. But again, you're now back to, instead of having one nice clean deployment, it's like deploy, deploy, deploy again. And every time you're updating the configuration. So you now get these, you're trading off like really complicated deployment processes for something that's really simple. But the other reason that I really wanted to do this was I wanted to get that sort of that redrive going, so that when we did have a problem, and we did actually have a problem once where we deployed a version of it and then said, yep, all good to go, and somehow managed to deploy the wrong version, and it literally did fail. I think it was like with 5,000 images or something like that. So the ability to really quickly and easily do that redrive was an absolute lifesaver at that point.
Take us through the redrive and how you trigger it, Rich. It's one of the questions that have come through from Chandra, and I've got a question also from Chris after that.
Yep. So the redrive is just a regular Lambda function. I literally just give it the ability to read from one queue and write to another queue. And then I just trigger that manually. So I don't, there's no event on that. I just have to go into the console and actually trigger it.
What if you've got like 5,000 images left in the queue? Do you need to trigger it 5,000 times, or does it kind of?
No, it'll drain the queue and then stop at the end of it. So it's like it's a one and done solution. So you only really need to fire that when you've got a problem.
Yeah, cool. Chris has asked, would it be more reliable to compare output and source directories to determine failures instead of using dead letter queue and Lambda redrive? Have you, I guess, compared each approach?
I haven't compared both approaches. You could definitely do that and just have something that runs on a regular basis and generates an alert. perfectly valid solution as well. I just like the immediateness of this. I mean, yes, you can sort of have a Lambda run every 5 minutes and compare it, but then I guess you've sort of got the problem of, well, if you're restricting the Lambda that's doing the resizing and somebody does put a large number of images in there, what happens if it takes a while for it to go through? You're going to get a false alert potentially just because the check ran while you were halfway through processing the images, or
yeah, I guess there's a lot of benefit to using dead letter queues because it's I guess a bit more event driven perhaps.
Yep.
Yeah, cool. Yes, I was joking with you on Twitter saying, oh gosh, image resizing, isn't this a pretty basic hello world? But obviously in a production environment where you absolutely must ensure that everything gets done correctly, there's that additional need for all these checks and balances. So, and this is really cool. It's I love these presentations where you're kind of actually talking about, hey, this hello world example, this is how it actually works in production, and where you've battle hardening it a bit.
Yep. Yeah, and we also have, so in this year, I've just talked about the resize. We do actually have another set of Lambda which deal with things like images being deleted, for example. So if they try to delete an image, then from the source, then again, we want to delete all traces of it from the destination so that we don't end up with images that are in one but not in the other.
Yeah. Okay, so Chandra's got a follow-up question. How would you handle if thousands of messages end up in a dead letter queue? Should the Lambda be manually triggered thousands of times, or does it just, you said that it gets placed on that SQS queue, is it?
You just trigger it once. So what it will do is it's a manually triggered Lambda. Once it starts, it's not event driven off the dead letter queue. It literally goes to the dead letter queue and then just drains it by doing a read on the queue. And it just does that in basically a loop until the queue is empty. Once the queue is empty, then it stops.
And do you get details of why a particular image might have failed in the dead letter queue, or do you have to go back to it?
Usually no. Usually I'm digging around somewhere else to try and figure out why that particular image failed. So CloudWatch. Really what's happening there is when it's failing, or at least when we did this, when it was failing, it was just doing the standard dead letter queue sort of notification thing. There was no sort of real error coming back at that point.
Mm. Yeah, very cool. Well, yeah, virtual round of applause. Thanks so much for popping by, Rich. Yeah, really appreciate the talk. Just some announcements before we wrap it up. We'll have a meetup pretty much same time next month. We may look to start meeting in person again, so stay tuned for those details. We can grab a slice of pizza and have a chat with one another. So that'll be good fun. Let's see how it all plays out. But really appreciate you all joining us today, and reach out if you'd like to present. Always on the lookout for some speakers. So yeah, thanks. And yeah, if you wanted to all hop off on mute and we can sort of have a quick chat. Otherwise,